Today's lesson is all about random samples and surveys. And really what it comes down to is what kind of information are you going to be presented? If you think about all that you are receiving, all the information you're receiving in the media, on TV, in magazines, online, everything you get is some kind of survey or results or percentage. This percent of doctors recommend this toothpaste, and this number of moms say that this is the best peanut butter, and all kinds of advertisements use survey results. We're going to talk just a little bit about surveys in terms of the sampling. Where do you get the best sampling? You will need your spiral notebook, and you need to have these 3 vocabulary words. Population is, you want to be able to find out about what? Sample would be, what piece of the population are you going to survey? If you want to know what moms recommend, well, you certainly can't survey all the moms in the world. That's too big of a task. You would take a small sample of the moms. Random sample, that sample that you take, are you taking it from one group? Are you taking all the moms who are 21? Are you taking all the moms who have high school kids? Or are you taking a random sampling? Are you taking a little bit here and there in different groups? Population, sample, and random sample. Make sure you know those vocabulary words. Pause the video if you need to, and then come on back and we'll continue on. All right, take a look at this word problem, and it's kind of personal to me, as you know, because I'm the recycling coordinator here at the school. If you want to know, gosh, I want to start this particular recycling program here at the school, and I want to know, is it really worth my time? Are we going to get people who actually will participate in that? The population is going to be, who are you asking about? Who are you interested to find out about? We're interested to find out about students at our school. We want to know what they think about recycling. That's the population. Who are we interested in knowing more about? In terms of the sampling, okay, you want to know if students across the entire school are going to participate in the recycling program. Well, at our school, we have about 1,400 students. Can we ask all 1,400 students? Well, we could, but it's going to be a really big undertaking to do that. So what can we do instead? We want to take a small sample of the students. We want to ask one group of students. How big of a group should we choose? And which students should we choose? Should we choose everybody who's at lunch between 12 and 1? Well, that would be all of our, 8th graders, right? Well, do we only want to know about what 8th graders think, or do we want to know what all the students think? You got to think about, if you're going to take a survey, who are you going to ask? Where are you going to take those people from? Certainly can't survey all 1,400 very efficiently. If you were going to take a good sample, which sampling would be the best choice? Should you interview every 10th person at the mall? Should you interview students in an ecology class? Or should you interview every 10th person leaving your school? What would be the best sampling based upon what we want to know? Well, interviewing every 10th person at the mall. Well, think about the people at the mall. Does that everybody at the mall go to our school? You got to remember what you're actually looking for. There's lots of people at the mall that wouldn't come to our school at all. Even if you chose kids in a certain age range, there are going to be some kids at the mall that go to a different school. That's not really going to relate to our school recycling program. So that one would not work. How about interviewing students in an ecology class? Well, ecology, if you don't know, is all about earth studies. Well, people who volunteer to take an ecology class, they're probably pretty environmentally conscious, right? People who really care about what's happening in our world in terms of recycling and being green. So people who are in an ecology class, probably quite a few of them will want to participate in recycling because that's what they're interested in. Do you see why that wouldn't make any sense? And finally, what about interviewing every 10th person leaving your school? Well, we are definitely choosing people from our school, so that's a good start. If we do every 10th person, is that random? Is that a random sampling? Yes, it is. You're not actually choosing and saying, I'm only going to take 8th graders, or I'm only going to take boys, or I'm only going to take people who are interested in coming up to coming up to recycling bins in the school, you're taking a random every 10th person, no matter who they are, the 10th person that comes out, that's who you're going to ask the question to. So not only is that a sample, but it's also a random sample. A random sample. You really got to think through these and think carefully about what you're asking to figure out where you should take your sample from. And a lot of times in our advertising and in our society, the information that's presented to us as fact, 82% of dentists say this is the best toothpaste. Well, who did they survey? Who did they actually ask? Did they ask only the people, only the dentists that take that particular product into the office as a free sample? Well, if they're already taking the free sample, maybe they already like the toothpaste. Are they taking dentists from across the country or in just one certain area where there's a very limited amount of manufactured toothpaste companies? It makes a big difference from who is being sampled. They don't always tell you that in society and in advertising and the media. So you really have to try to think through some of the numbers that are being presented to you, because they might not always be exactly what they intend it to be. They're going to try to mislead you. Remember hearing about propaganda in language arts? Take a look at this example. You want to find out how popular basketball is at your school. Okay. Jot this example down in your spiral notebook and write down what the population is, and I want you to decide where can you get a good sample and try to make it so that you could get a good random sampling. Write down whatever ideas you have. In class, you're going to share them in your groups. Go ahead and jot down what you think. All right. We're going to share those answers in your groups. But for right now, let's go ahead and move on. Take a look at this next example. TI, you know the people who make our calculators. TI produces 20,000 calculators, and a random sample is selected. You have a manufacturing company that makes a lot of one thing, but they're not going to check every single calculator. They're going to take a random sampling. Here's a random 500 calculators that they've taken off the conveyor belts and selected them to check to see if they work. And they found that out of those 500 calculators, 3 of them are defective. Well, if 3 of the 500 are defective, how many of the 20,000 is defective? Think about that. If you've ever seen the This Is How They Make It shows, or if you've ever gone on vacation to various places, even Hershey Park. I've been to Hershey Park where you get to go and see how the chocolate's made. They take a sampling of their products to see, is it good quality? Is it tasting the way they want it to taste? Or is it working the way they want it to work? They certainly can't test, we wish they did, but they can't test all 20,000 calculators to see if they work because it would take too much time. It would take away from their production. So what they do is they take a small sample, in this case it's 500, which is small compared to our number here. A small sample to see if they work. This is called an estimate because they aren't actually testing all 20,000. We can only anticipate. So if there's 3 out of 500 are defective, we want to know how many out of 20,000. Notice the total numbers always go on the bottom, the total sample that they chose or the total that they actually produced. This is how many defective ones in the sample. We want to know how many defective in the total. So do you notice how the words are similar? This is the total sample. This is the total number that they picked. This is the number defective in the sample. This is the total defective from the entire plant. Try to make sure, you have to make sure your numbers line up. Okay? This is called a proportion because you have 2 fractions equal to each other. Do you remember how to do this kind of problem? You're going to do cross multiplying and then divide by the number that's left. 3 times 20,000 and then divide by that 500 that's left. 3 times 20,000 divide by 500. You get 120. That reminds me, this next example I want you to try, you might need a calculator. So if you need to pause the video, go grab one. Here's one for you to try. Go ahead and read it carefully, Pause the video and see if you can figure out the estimated number of students. Okay, did you set up a proportion? Our totals are always going to go on the denominators. We have the total number of students, and we have the total sample that we chose. Totals have to go side to side, matching up. The numerators will be our numbers of students who said yes. So we had out of 30, 10 said yes. How many out of 122 can we predict? Another keyword might be predict. So instead of estimate, you might see predict here. Means the same thing. So you're going to cross multiply 10 times 122 and then divide by the number that's left. You did need a calculator, didn't you? I totally forgot. All right, so this would be 40.6 repeating, right? So let's round that. That would be approximately how many students on the team might say that they play Frisbee golf? 41. 41 out of 122, we predict, would say that they play Frisbee golf. We're taking our sampling and applying it to the total population. We're going to do some more practice problems in class, and you will see some of this on your test as well. See you soon.